In 1797, Henry Cavendish, the British scientist, Freemason, and wealthy grandson of the Duke of Devonshire, created an experiment which he claimed successfully proved the existence of gravity, measured its constant, and provided accurate figures for the exact masses of the Earth, Sun, Moon, and planets. How did Cavendish achieve this quantum leap for heliocentric pseudoscience? He fixed two large lead balls on opposite ends of a torsion balance and hung them from the roof of his shed. By watching and recording slight motions of the contraption via telescope through his shed window so his mass would not affect the reading, Cavendish claimed to have proven gravity. Two small lead balls were hung near the large ones, and any motion observed towards one another was touted as being the influence of gravity. Now, the Cavendish experiment has been widely criticized by the scientific community because never in over 2 centuries since its creation has anyone been able to replicate it. Firstly, the balls simply do not always attract one another, as they must, for the so-called gravitational constant to be constant at all. Sometimes the torsion balance turns towards the balls, and sometimes away, as it is impossible not to give some slight tremulous motion when interacting with it. Henry even complained in his notes how often as he was performing the measurement, the contraption was still in oscillation. Secondly, since his calculated force of gravity was 10 to the 39th power weaker than the force of electromagnetism, from which all material objects are composed, there is no control for the experiment, which can factor out and positively differentiate the alleged gravitational force from the known, stronger electromagnetic force. In other words, the balls could simply be attracting each other through static electricity, a known force existing in all things, billions of times stronger than gravity, and impossible to control for the experiment. Even though no one could replicate Cavendish's findings, the experiment went down in history as a great success, and is still taught as veritable proof of universal gravitation in science textbooks today.
Welcome to my classroom. And what I have behind me here is my attempt to reproduce the Cavendish experiment. For my setup, what I have are 2 meter sticks which have been taped together. And on either end of these 2 meter sticks, held there with some paper clips, are 2 1-kilogram masses on each end. Now this meter stick is being hung by a copper wire which runs all the way up to the top of this very large piece of wood, which I have separated out and have supported up on lab tables with some physical science and AP chemistry textbooks. This experiment is quite sensitive to air currents. And that's also why, as I talk about this, I'm showing you plenty of footage with a clock in the background, so that way you can see by just sliding that YouTube bar how much or how little movement is actually happening. And before we do the experiment, we're going to get plenty of footage too as to the lack of movement prior to adding the masses compared to the movement that we have after adding the masses. And so for the masses, this is a lead brick. And I'll be massing this in a little bit here so you can see just how heavy we're talking about. But 25, 30 pounds, somewhere around there, I'm just guessing. So that's about a little bit over 26 pounds. When it comes to the Cavendish experiment, it's not just about how much mass you use, it's also about how much volume it's taking up. If you had something really large and massive like a car, well, that also takes up a whole lot of volume. And when it comes to gravitational effects, it's not just about the mass, it's also about the distance squared between the 2 objects. So yes, you want something very massive, but you also want it to take up not too much space, so that way you can get the hanging masses over there on the Cavendish experiment to be able to get close to the center of mass of your objects. downward angle, we can see the torsion balance's amplitude. This is the noise in the experiment, due to imperfections in conditions, imperfections in the setup. From the left-hand side of the torsion balance, you could say the lowermost limit and the uppermost limit. That represents the amplitude, the noise in our experiment. When the lead bricks are put in place, the torsion balance was already moving counterclockwise. Yet, notice it does not reach the previous maximum counterclockwise position. If there was no attraction to the lead bricks, then adding the lead bricks should not have prevented in any way, shape, or form the torsion balance from just continuing on to that maximum counterclockwise position. An acceleration on a mass is due to a force. The lead bricks are exhibiting a force of attraction on the masses of the torsion balance. This is the gravitational effect of the lead bricks disrupting the previous equilibrium. Continue to watch though, and the effect is even more obvious and pronounced. In high speeds, once the very dense lead bricks are brought in, the masses of the torsion balance are observed to be physically drawn to them. The faster we play back the footage, the more blatantly obvious it is.